Hi again. So just now we have go over the notes. So now we go over the question that follows. Okay. So on the reflections of light. So you are given this picture. This is the registration number of a car. So if you look at this in a mirror, how will the image be? Right. So what do I know about image of plane mirror? I do know it must be laterally inverted. Okay, upright. So which of these are laterally inverted? Okay, I saw this one is laterally inverted. Not this one, definitely not this one, and also not this one. When I say literally inverted, I see B on my right, it will become on my left. Sorry, this B is on my left, it should be on my right. Okay, so B is on my right. So this one no, this one no. Okay, this one it is on my right. Okay, but and then we look at 5 here, it's on the right. Okay, so in the mirror it will be on your left. Okay, so it's on your left, and this one here is also on your left. All right, so we only have two choices now, is A and also B. All right, but then look at how this 5. Okay, this 5, it is not laterally inverted, right? Even this L is not also laterally inverted. So that's why the answer here must be A. Okay. Question number 2, you are to find the distance between the flower pot and the image of the man. Okay. So here is my flower pot. Okay. So I mark here. Okay. Let's say here X. And then the image of the man. Okay. The man is standing 4 meter in front of the mirror. So the image would be 4 meter behind the mirror. So this here would be the image of the man, right? So here is 4 meter, and from here to the mirror is 3 meter. So what is the distance? So the distance would be 3 plus 4. So the distance is 7 meter. Okay, we go to the next one. Okay, a student stand in front of a curved mirror and do some action at X. Okay, the distance is 0.8 meter. Okay, so the distance here is 0.8 meter. The image form is upright. Okay, diminished. So here are the characteristics. Upright and diminished. Okay, name the type of mirror, of curved mirror. Okay, so this curved mirror, so this must be a convex. Okay, here I have a convex mirror. Okay, so if I do this like this, so I can see that this side is facing the man, so this must be a convex mirror. And then state the light phenomenon involved. Okay, it is simple. This must be reflection, pantulan. Okay, number 4. Ahmad is moving. Let's say it's moving to the right with velocity of 2 meter per second. Okay, and then his image will be moving in the opposite direction, also 2 meter per second. So what is the relative velocity? So the velocity must be 2 plus 2 equals 4 meter per second. So that is the speed of Ahmad and his image approaching each other. Okay, number 5. Okay, complete the ray diagram below. Okay, so I have an object here, so I want to know where is the image. So the image, I do know that the distance from the object to the mirror must equal to the distance from the mirror to the object. So I make sure that these two, they must be of the same distance. So I know that my object will be here. So what I do next is I just draw two lines going straight to the eyes. If you recall the note just now, we draw two lines straight to the eyes, and then So from these two lines that we draw, okay, we draw the normal. Okay, the normal, and then from this intersection between this line and the surface of the mirror, we draw another line going straight to the object. So you do the same thing for the green line here, reflected towards the object. Okay, so if I check my angle here and this angle here, they must be the same. Okay, same thing goes to this angle here and this angle here. Okay, but this picture is not yet complete. We must draw the direction of the light propagation. So light travel from the object, okay, towards the mirror and then reflected to the eyes. So I'll do the same thing on the green lines, okay. So it's going towards the mirror and then reflected towards the eyes. And it follows the law of reflection, which says that I must equals R. Okay, so let's go to question number 6. So for question 6, you have 4 points A, B, C, and D placed in front of a plane mirror, MN, and you want to know which point object can be seen by the eye. Okay, so same method. Okay, I measure the distance from the object to the mirror. So for this case, I draw a reference line here, okay, to denote where my surface of the mirror is. So I draw a line and I measure the distance perpendicularly from this point to the mirror. Okay, so these two lines must be of the same length. Same thing goes to this line here must be the same length. This line here must be the same length. Okay, and then this line here and this line here must be the same length. Right? So the object must be formed here. Okay, so here are the possible object. Okay, so what I do next is from the object I draw a line straight to the eye. Okay, line straight to the eye. Same thing goes to this point. Okay, maybe I put here D prime, C prime, okay, B prime, and A prime, okay, to denote the image. Okay, so D prime, I draw straight line going to the eye, and then I do the same thing for C prime, straight to the eye. Okay, do the same thing for B prime and also A prime. Okay, now check your line. So I have 4 lines here. Which one hit the surface of the mirror? So it's only the red line hit the surface of the mirror. Okay, meaning that this line, okay, this line here will allow the observer to see the image, okay, whereby I have an object, the light going and the light going to the mirror, okay, and then it will be reflected entering the eyes. So I can draw my normal line, my normal here. You can check that this angle of incident must equal to this angle of reflection. So if you look at this line, the blue, the purple, and the green one, it doesn't hit the surface of the mirror, so you won't be able to see the object. Okay, follow. Alright, so next, complete the ray diagram for curved mirror. Okay, for curved mirror. So here is my mirror. Okay, if I complete my circle, so I am going to use the C and the F inside my circle. Okay, so recall I have a line parallel to the principal axis, and what happened? It will go to my focal length. Okay, and if I draw a line going through this focal length, upon hitting the mirror, it will go straight. Okay, and the third line, okay, the one I'm not sure what color is this. Is it orange? Okay, it will go through C. Okay, go through C, and after it hit the mirror, it will be reflected on the same line. Remember? Okay, and then next you find where all those lines intersect one another. Actually, you need to draw 2 lines. Okay, 2 lines is enough to find the intersection. Okay, so I can see that they all intersect here. So I draw the head of the arrow here, and then the foot will be on my principal axis. But this picture is not yet completed. I must draw the directions of the light propagation. Okay, so here is the direction of the light propagation. So incident, reflected. Okay, so incident and then reflected on the same line. All right, follow. So for question 7b onward, you will see that I will be using the same color. Okay, the red line would be parallel to my principal axis. The blue line will go through my focal length, and this orange line will go through my center of curvature. Okay, so the image would be here. So this image, as you can see from the drawing, it is diminished. Okay, smaller, diminished, and then I can also see that it is also inverted or upside down, and then it is real. Okay, so remember that concave mirror, for mirrors and also for lenses, when it comes to real versus virtual, they always contradict each other. Okay, so for this one, it is real because object and image on the same side. Okay, however, if we are to use a convex, if I have object and image on the same side, then it must be virtual. But for mirror, object and image on the same side, then this image must be real. Okay, let's do another one. Okay, so again, okay, here is my mirror, my concave mirror. If I complete this circle, I know that I'm going to use this C and this F. Okay, now I draw a line parallel to my principal axis. Okay, that is my incident ray, and it will be reflected towards my focal point. Okay, and then another line, I draw it passing through my focal point. After hitting the mirror, okay, here is the incident ray. After hitting the mirror, it will go out parallel to the principal axis. Okay, so this blue and the red line intersect at this point here. So here is my image. So what is the characteristic of the image? Okay, same size, right? See here, two boxes, here also two boxes. So same size, real, and also inverted. Okay, follow. So it's same size, inverted, and then real. Okay, let's move on to the next one, C. Okay, again, if I draw a circle, it go like this. So I'm going to use my this C and also this F, right? So first, draw a line parallel to my principal axis, and then reflected passing through my focal point. Okay, right. So, and then we draw the blue line passing through our focal point. Okay, going towards the mirror. After hitting the mirror, it will be reflected. Okay, reflected parallel to our principal axis. And then find where these two, this red and this blue line intersect. So it intersect here. Okay, so arrow down here, and then the foot is on the principal axis. So what is the characteristic of this image? Okay, now I see it is still inverted, right? Inverted. The size, how? Okay, the size, it is magnified, and then real or virtual, object and image on the same side. For mirror, it is real. Okay, so the image magnified, real, and inverted. Okay, we move on to the next one. Okay, now I put my object distance equal to my focal length. It's at my focal point. Okay, now, so again, if I complete my circle, you are going to use this C and this F, right? Okay, so first I draw a line parallel to my principal axis, and then what happened to that line? It will be reflected passing through my focal point. Okay, so this is my reflected ray. And then I don't want to draw going through F because it will means nothing. Okay, so I will draw a line passing through C. So what do I know about the line passing through C? Okay, it will go hitting the mirror and then it will be reflected on the same line. Okay, so that is the ray that is passing through my point C here. So observe these two lines here, the red and also the orange line. So these two lines seems to be parallel, so they are not going to intersect. Okay, so for this image it must be formed at infinity. Okay, so here I can write image at infinity. Okay, we move on. Okay, now still concave mirror. Okay, if I complete my circle, so still I'm using this C and this F. Okay, so here is my object. So first I draw a line parallel to my principal axis, right? What happened? It will be reflected passing through my focal point. Okay, so this is my reflected ray. Okay, next line. Again, I'm not going to use my F here. Okay, I'm going to use my C. Remember that you need to draw two lines is enough to find where the image will be formed. If you want to draw three lines, okay, go ahead, but actually no need because you only need to draw two lines. Okay, so let's see this orange line. It passing through my C, so it go hitting my mirror. Okay, so here hitting my mirror and it will be reflected, okay, on the same line. So if you look at these two lines and find where these two lines will intersect, so it will intersect on the right. So I will elongate the line, make the line longer and to see where it is where these two lines will intersect. So I found out that it intersect at this point here, so I draw the image here. So here I'm using the head of the arrow, so at this point of intersection is where the head of the arrow will be and the foot will be on my principal axis. All right, so I draw here dash line because this is in the mirror. Okay, it's in the mirror, so it's not on the screen, it's in the mirror. So what can you say about this image? First, upright, correct? Second, magnified. Now virtual or real? Now I have object and image, okay, on different side. Okay, so if they are on different sides, then this image must be virtual. So the characteristic of the image are magnified, okay, virtual, and upright. Okay, now let's see this one here. Okay, so now I have a convex mirror. If I complete my circle, okay, I will have something like this, right? So you are going to use this F. Okay, in this example, you don't have any C, but you can always pinpoint where your C is. You see here, I have 1, 2, 3, 4, 1, 2, 3, 4, right? So 1, 2, 3, 4. Here is my F, and then 1, 2, 3, 4. So my C will be here. Okay, follow? Well, anyway, so look at the red line. So I draw a line parallel, okay, to my principal axis, and I know that it will be reflected going up. Okay, going up from where? It's going up from this focal point. All right, and then next I draw the blue line. The blue line, I will draw it such that it will passing through my focal point. So what happened at this mirror? Okay, so here is my incident ray. The reflected ray, it will be parallel to my principal axis. Okay, so next is find where the line will intersect. So you need to elongate, make the line longer to see where these two lines will intersect. So I see that it intersect at this point here. So here is my image. So the image here, it is upright, okay, upright, and then diminished, and then lastly it is also virtual. As I said earlier, okay, you need to draw at least two lines so that you can see where these two lines intersect. Okay, for example here I'm using the line that is parallel, and then the second line passing through my focal point. Okay, so if I am to use my C, okay, here is my C. Okay, so here is the line just now parallel to my principal axis. Okay, and then it must be reflected, but reflected from my focal point. So this orange line, okay, I project it to the mirror, and it is passing through my center of curvature. All right, so it's going towards the mirror, and it will be reflected on the same line because it go through C. Okay, so can you see where the red line and this orange line intersect? Again, it is here. Okay, can you see it clearly? Okay, so I make it a bit larger so that you can see. All right, so it intersects here. So if I am to compare this image and this object, I can see that this image, it is diminished, becomes smaller, upright, okay, and then since the image and the object not on the same side, then this image must be virtual. All right, so we continue with question 8. All right, diagram shows an observer looking at the image of a fish 50 centimeter from the water surface. What is the actual depth of the fish? Okay, so I want to know what is the actual depth. Here is the image. So what do I know about this? I do know that the refractive index, okay, equal to our actual depth divided by apparent depth. Okay, actual depth divided by our apparent depth. Okay, so our actual depth is what we don't know, so I will just put it as D. Okay, and then apparent depth is this distance here, that will be 50 centimeter. Okay, but at the same time you are also given angle of incidence and angle of refraction. Okay, so I do also know that N is equal to sin I over sin R, and then this value must be greater than 1. Okay, so let's check. Suppose I have sine of 35 divided by sine of 50. What do you get? Okay, you will get 0.7488. Okay, so this cannot be the value for my refractive index. So I have to take the reciprocal. Okay, so here is my refractive index. So N must be sine of 50 degree divided by sine of 35 degree. So here you will get 1.3356. Okay, so I substitute this value into this equation here. So N is 1.3356. So you solve for D, yeah? So you calculate D, that will be 66.78 centimeter. So this is the actual depth of the fish. Okay, so the fish must be underneath the image. So here is the fish. So I'm using the formula for refractive index using the depth and also trigonometry, yeah, the sine. Okay, we go to question number 9. Okay, now you are given the velocity of light in vacuum, okay, and then you are also given the refractive index of glass block 1.6. All right, so what are the formula for refractive index? So refractive index equal to the velocity in vacuum, right? Divided by velocity in a medium. For example, here I have a glass block. Okay, so we are given the refractive index. We are given the velocity of light in vacuum. So refractive index is 1.60 equal to, okay, velocity in vacuum is 3 times 10 to the power of 8 meter per second divided by the velocity of light in medium or in the glass block. So solve for this V. So that V, okay, if you use a calculator to find the value, it should be 1.875 times 10 to the power of 8 meter per second. So that is the velocity of the light in the glass block. Okay, can you follow? Okay, so we go to the next one. Okay, in this diagram we are using a periscope. Okay, in this periscope we are using a glass prism. So here's the object. Okay, so I just draw the light in red and then another one in blue. So the light going to the prism, it hit at this end here, it will be reflected. Okay, it going down after hitting this line here, okay, the hypotenuse of this prism, it will be reflected. Okay, so you see here I'm using the head of this arrow, so all these are the head of the arrow. That's why here is the head of the arrow. And then the foot, okay, the foot here, I draw a line going straight to hitting the prism. So it's going that way and then being reflected. Upon hitting here, it will be reflected. So what we are having here is total internal reflection. It happened inside the glass prism. Okay, so state the principle of light used in the periscope. That will be total internal reflection. Pantulan dalam penuh. Alright, so if the refractive index of the prism is 1.5, calculate the critical angle of the prism. Okay, what formula are we going to use? Okay, so n equals to 1 over sine of C, right? So we are given the refractive index is 1.5 equals 1 over sine C. So can you find your C now? Yes, right? So plug it into your calculator. You should be able to get your C equals 41.81 degree. Alright. So we are just using our formula for refractive index given the critical angle. And that's why you need to be very well versed with the refractive index formula. Okay, C, we have done that. Okay, D, explain why using prism in periscope is far more effective than using a plane mirror. Okay, plane mirror versus prism. The reason is prism will produce clearer image. However, for a plane mirror, okay, the surface of the plane mirror sometimes it is not really that smooth, and furthermore it can produce double image due to multiple reflection. Okay, so mirrors produce blurred image due to multiple reflection. That's the reason why using prisms in periscope is far better than using plain mirrors. Okay, state other application that use the same principle, just like in periscope. Uh, the easiest one would be a binocular. Okay, binocular using the same principle. Okay, other than binocular, we have fiber optic. Okay, what principle are we talking about? We are talking about this one here, total internal reflection. Alright, so let's move on to question number 11. A diagram shows a light ray entering a semicircular glass block and being refracted. What is the refractive index of the glass block? So I see a light and then it's being refracted, okay, at the surface here. So what do I know? I do know that this angle here must equal to our critical angle. If this angle here is less, then I will have something going out from the glass block, right? If this angle is greater than my C, then it will be reflected inside. If it is equal, then it will be on the surface between the two medium. Right, so this must be my critical angle. So if this is 53, so what is the value of our C? That will be 90 minus 53 degree. You should be able to get a 37 degree. So your critical angle is 37 degree. The question asks for what? It asks for refractive index. So remember our n just now, n equal to 1 over sine C. Okay, so 1 over sine of 37 degree. So you will get the answer 1.66. Okay, simple, right? Alright. Let's move on. Now we go to lenses. Complete the ray diagram for lenses below and then state the characteristic of image form. Okay, so here I draw line in red and line in blue. So you will see that I will use the same convention onwards. Okay, so how do we draw ray diagram for lenses? So first I draw a line parallel to my principal axis. Okay, and then what happened to that line? It will be converged to my focal point. Okay, just draw the line passing through the focal point, right? So make sure you have this arrow to show the direction of the light propagation. Okay, next I draw the blue line hitting the optical center. What happened? It will just go straight. The light will not be deviated. There's no deviation, no deflection if it passing through the center of the optic. So what is next? Find where the red line and the blue line intersect. So it intersect here, right? So the head of the arrow must be here, and then the foot must be on the principal axis. Okay, now compare object and the image. First, I do know it is smaller, so diminished. And then it is inverted, upside down. Real or virtual? Remember what I said? Mirrors and lenses, they contradict each other when it comes to virtual and real, right? So for lenses, if the image is formed on the other side, then this image must be real. Okay, so this image is real. Follow? So the characteristic of this image is upside down, diminished, and real. Okay, let's move on to the next one. Okay, so we just follow the same thing. The red line, okay, parallel to my principal axis. Okay, and then after hitting this optical axis, it must go hitting my focal point, right? And then the blue line, it will go through my optical center and it will just go straight. And then next, determine where the red line and the blue line intersect. So it intersect here, so my image will be formed here. Alright, so what are the characteristics of this image? Okay, first, inverted, correct? Inverted. The size, okay, the size, two boxes. Here also two boxes, so the size must be same size. Real or virtual? The image is on the other side, so this image must be real. Alright, okay, we go to C now. Okay, we're just doing the same thing. We draw the red line parallel to our principal axis and then go through our focal point. Okay, done with the red line. Now the blue line from the head of the arrow going through the optical center. It will just go straight, no deviation. And then next, find where the red line and the blue line intersect. So it intersect here. So here is the head of the arrow, the foot on the principal axis. And then lastly, determine the characteristic of the image. Okay, so I can see it's larger. The image is larger than the object, so it is magnified. Okay, magnified. And then it is also inverted, upside down, right? Inverted. And then real or virtual. Okay, again here it is real because the image is on the other side. All right. Now we move on. Okay, same thing. So here is my object. So I draw a red line parallel to my principal axis. And then after hitting this optical axis, it will hit my focal point. Okay. Hit my focal point, or just draw the line. Okay, and then the blue line here, it will go through the optical center, so just draw the line going straight. All right, and then you examine these two lines, where are they going to intersect? So it seems to me that these two lines are parallel. Okay, garisan ini adalah selari, okay, parallel, so they are not going to intersect. So what about the image? So the image will be at infinity. Okay, so image at infinity. Okay, now next one. Okay, we are still working with a convex lens. The same step, right? So red line parallel to our principal axis. After hitting the axis of the optic, it will go hitting my focal point. Okay, it must go through the focal point. And then the blue line, it go through my optical center. All right, so what happened to that blue line? It will just go straight. Okay, just go straight, right? And I do know that these two lines, they are not parallel, so they must intersect at one point. So just make the line longer, 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 longer. Okay, so I can see that the two lines intersect at this point here, right? So here is the point of intersection. Then the head of the arrow must be here, and then the foot must be on the principal axis, right? Follow. So here I must draw dash line because these lines are imaginary lines. Okay, so now compare the object and the image. First, I do know that the object is magnified, right? Correct. Here only two boxes. Here I have 1, 2, 3, 4, 5. 5 boxes. So the characteristic of the image are magnified, and then they are upright. Okay, the image is upright, and then virtual or real. So now my image and my object are on the same side. So this image must be virtual. Oops. Okay, so this image must be virtual. Okay, other than virtual, it is magnified. And then it is upright. Okay, remember our note just now, we must mention these three if you are asked the characteristic of the image. Okay, can you follow so far? Okay, so we are done with convex lens, so let's go to concave lens. Alright, so the same thing, the red line is parallel, okay, parallel to my principal axis, and what happened? This line, this ray, it will be diverge. Okay, diverge from where? Diverge from this focal point. Alright, and then we draw, sorry, I need to draw this arrow first. Okay, and then the blue line, it will go through the optical center. So what happened? It go through the optical center, it will just go straight. Okay, no deviation. So next, find where the blue line and the red line intersect. So it intersect at this point here. So the image will be at this point. So here is your image. So what are the characteristics of the image? First, I do know that this image, it is smaller than the object. So it is diminished. Okay, the size becomes smaller. What about the position here? Okay, I can see the head is going up. So here it must be up, right. Now, virtual or real? Object and image on the same side. For lens, this must be virtual. Okay, so that's how we draw the ray diagram for lenses. Okay, let's move on. Okay, now you are given an object placed 10 centimeter in front of a converging lens. Okay, so you are using a converging lens. So this is our convex lens. Okay, another name for convex lens is converging lens, kanta penumpu. Why we call it as kanta penumpu? Because the ray will be tumpu, will be converted to a focal point. That's why we call it as a kanta penumpu. Ditumpu ke titik fokus. And the focal length is 15 centimeter. Okay, so what is this thing here? This is our object distance, right? And here is my focal length. So you are to find, okay, calculate the image distance and state the characteristic of the image form. All right, so I have u equal to 10 centimeter, and then I have convex lens. I merely writing down the info that I get from the questions. And then I have f equals 15 centimeter. So what formula am I going to use? Okay, in lenses, I have this formula. 1 over f equals 1 over u plus 1 over v. Okay, so just plug in the value. 1 over 15 equals 1 over 10 plus 1 over v. So you solve for v, okay, you should be able to get your v equals negative 30 centimeter. Okay, so this negative tells us that the image, okay, it must be virtual. Okay, next one. Determine the power of the lens. So how do we find power? Power equal 1 over focal length. But this focal length must be in meter. So do not make the careless mistake in using centimeter in place of meter. Alright? So F given in the questions is 15 centimeter. So convert this to meter, you should be able to get 0.15 meter, correct? So just plug in the value. So P equals 1 over 0.15. Alright, so that will give you 6.67 diopter. Okay, follow. Alright, so let's move to question number 14. So you are given lens A and lens C, D and F. Okay, A and C are concave, D and F are convex. Okay, how are you going to make a compound microscope? Okay, we want to make a microscope. So remember, microscope, we do not use concave, we use convex. So we are going to use D and F. Alright, now next step. For a microscope, we do have our eyepiece and our objective lens. Alright, so let's say that FO is the focal length of the objective lens, and then my FE is the focal length of my eyepiece. So for a microscope, FO must be less than my FE. So which of these supposed to be your objective lens and which one is supposed to be your eyepiece? Okay, so objective lens, I must use lens. The smaller one, that will be lens D. And then for eyepiece lens, we are going to use lens F. Right? Follow. So D as our objective lens and F as our eyepiece lens. Alright. So that is point number 1, right? We have 2 points. One is the focal length, and then the second one is the distance between the lenses. Alright. So the distance between the lenses must be greater, right? Greater than FO plus FE. Okay. So let's say it's a distance. Maybe I put a notation here, L. So L must be greater than FO is what? FO is 5, FE is 15. Therefore, the length must be greater than 20 centimeter. So that's how you arrange the lenses to make a compound microscope. Okay, using the same information, how are you going to build an astronomical telescope? So for a telescope, again, we have to use convex lens, right? Now, what about FO versus FE? Okay, so for a telescope, you are using it to see far away object. So FO must be greater than FE. Okay, therefore, your objective lens you are going to use lens what? Which one is greater? Okay, lens F. So here use lens F as our objective lens, and then for our eyepiece, we use our lens D. And then that is our first point. The second point will be the distance. Okay, so the distance between the lenses must be equal, right? Equal to FO plus FE. That will be 15 plus 5 equals 20 centimeter. Okay, so that's how you build a telescope and also a microscope respectively. Yeah. All right. So I stop here first and see you again later on.